The robots are here. The new technology that is emerging within the field of robotics is accompanied with many different challenges and fears. Robots, for many people, mean the potential for the end of work, bring new and scary ethical questions, as well as many other challenges we can't even think about yet. We know all too well that we risk losing a lot because of robots. But what do we stand to gain through them?
Dr. Martin Stolen is hoping that his latest project is going to create a new shift in the agricultural industry.
So Gumiam is something that came out of a research project I was doing here, where I was actually looking at not agriculture at that point in time. I was looking more at how robots can learn or develop skills from kind of almost on a clean sheet.
Gumiam was the result of a problem in modern robotics, allowing machines to explore their environment without breaking.
The arm design that came out of it was basically largely inspired by the human arm. So it has this, for every joint it has at least a pair of actuators moving the joint, but also being able to vary the stiffness. So you can have, just like we can have a biceps and a triceps, and if you can move the joint, but you can also pull on both of them to make the joint stiffer.
Gumiam's adaptable flexibility makes it suitable in many different environments, meaning that robotic machines will soon be able to work outside factories.
If you have let's say a producer where a lot of times their costs are highly driven by the manual harvesting. Sometimes it's more than 50% of their costs. This is imported labor. There's few people here in the UK or in Europe that are willing to go out in the field and do this job. So we feel like if we can develop systems that can operate robustly and efficiently, effectively in the field, then we can help them reduce their costs and be more productive.
There is little doubt that this will create major redundancy in labour work, but by putting the 3D printable designs online, Dr. Stolen hopes to create a new potential for businesses to utilise this technology.
We're hoping this will generate a bit of a community where people can share their designs as they develop, and we can see have benefit and synergies across the different groups working on it. So I think those are the things. That is variable stiffness, it is 3D printable, and it's open source. It makes it a unique arm.
Gumiam doesn't need to mean the end of work, rather a change for it. A chance to create new enterprise by utilising this technology.
Okay, so this is an inverted pendulum, which is a classical problem in control engineering. So the idea is we have a pendulum, it's normally hanging downward. If I now move it, so it's inverted, the stabilisation should switch in when it gets right vertical.
Dr. Ian Howard is a scientist with a unique method of understanding the world, building.
I'm interested in building real systems because then we basically have to deal with the real world and the real physical universe, if you like.
It's quite stable in this configuration. It's using state feedback control, so I should be able to perturb the end with a large flask in this case, and it should still be able to keep it standing up. Don't want to overdo it though. You do the same thing again with a nice little brass weight.
I think it's very much an engineering approach to doing things. So I'm sort of halfway between being a scientist and engineer. So I think it's a very, very valuable way of proving our theories and making us look critically at what we think we understand. And it certainly is, I think, an extension of engineering and scientific thought in that sense.
Dr. Howard has applied this method of understanding and turned it towards us. In his lab, he looks at the way the human brain learns movement.
So this is a demonstration program for the VBot manipulandum. And basically the idea is, with the VBot, you're holding a handle, it can record your position, and we can use this to plot the position of this cursor, which is the white dot here.
We can give people things, movement, experiences which represent kind of novel dynamics, and look how they learn them, or look how they can't learn them.
Through the insights of VBot, we can see that talent, specifically with sport, may be more programmable than we think.
Using this kind of approach, what we've actually shown is the lead-in movement, if you like, which is like the backswing, let's say, of a tennis stroke, very, very strongly affects what you do next. It very strongly affects how you learn things in the next movement, and very strongly affects how you recall things. If you have a very variable lead-in, it'll actually slow down how fast you can actually learn stuff. So, we've showed that you've got a very variable lead-in followed by a new task to learn, or you have a very, very consistent lead-in followed by a new task to learn. The very consistent task you learn about twice as fast. If you're going to be a really good tennis player and you want to get a really good serve, you've also got to make sure that the backswing is also very, very precise, because it's going to affect how you recall the forward swing.
As we see, by building, we not only have the power to control the world and environment around us, we also have the ability to gain more control over ourselves. We've seen how robotics will potentially change businesses and ourselves, but the introduction of these robotics calls into question our future relationship with technology. At the Cognitive Robotics Lab, Samuel Venanzi is working on the issue of trust between people and robots. However, his approach is a bit different.
My research, though, doesn't regard the trust that goes from humans to robots, but the opposite, the trust that goes from robots to humans. In fact, my research title is "Would a Robot Trust You?"
One of Samuel's recent experiments, looking at trust, reveals a very unique and very human skill that might be possible to recreate in robots.
What's going to happen here is that I'm facing the robot in this moment. We've got a table with a sticker that can be moved in two positions, left or right. What's going to happen is that I'm going to put the sticker on the left or on the right, and I'm going to suggest the robot where to look to find the sticker. And the robot's going to follow blindly my suggestions. Based on the fact that he finds or doesn't find the sticker, he'll slowly start to learn wherever I'm a tricker or helper towards him.
Hello, Informer number 0. Please look at me. I am going to ask you to tell me where the sticker is. Can you suggest me the location of the sticker, left or right?
Right. We think that trust is directly derived from a mental skill or cognitive skill that's called theory of mind. It's the ability to understand that other people outside of ourselves have different mental states. So belief, desires, knowledge.
Excellent. Now I know you a little more. Thank you.
This trial is going to be repeated, but the robot will use its own judgment to decide if to trust me and follow my directions, or to not trust me and look at the opposite location of which I suggested him.
Hello again, Informer 0. Can you suggest me the location of the sticker, left or right?
Left. We've used the results from a psychological experiment by Kimberly Vanderbilt.
I was right not to trust you.
She put these children in front of interactors in a sticker finding game. So there was a table with some boxes, and the children needed to find a sticker located in one of those two. And they asked suggestions to these actors that were in front of them. These actors could be helpers or trickers, so they could actually indicate them the right position or the wrong position. In the last phase, the robot will look at the table and will say, okay, I see that the sticker is in that position, so probably you would have suggested me this one or that one, demonstrating to understand my mental life.
Through this experiment, we can see that such a complex skill can be taught to modern machines.
Robotics comes with a lot of problems.
Let me think.
It's not just technological problems, but it's as well ethical problems, social problems. So we're actually trying to introduce autonomous beings inside the society. And this can have a profound impact on lots of things like laws, economy.
I know the sticker is on the left. I believe you think the sticker is on the left. I also believe you would point right to me.
So I find it a really large and multidisciplinary problem that I really love to explore. I think that's really good food for mind.
With the development of theory of mind, Samuel hopes that our relationship with robots will be more successful going forward.
Emerging robots are very scary. They do bring with them many challenges and uncertainty.
I think that people are scared about robots as well. They think them like a threat to their own existence, sometimes in the most extreme cases, as well as their lifestyle. I think, and I'm profoundly convinced, that robots are just instruments, so they're technology that are used to support us in our daily lives.
However, despite any challenges, they also have the potential to give back a lot in return. Not just an easy lifestyle, but also new opportunities in business, understanding and collaboration.
I'm kind of looking at it from a scientific perspective. How can we use this kind of technology and interact with this kind of technology in order to understand how how the human brain works, how the human body works. So again, it's a very broad field of application.
You get inspiration from people of a lot of different backgrounds. We have multidisciplinary teams, and you feel that you can find new solutions in between these fields. That really drives me.
The robots are here, and while that may not be an easy thing, it will hopefully be worthwhile.
The experiment is ended. Thank you for your participation.